Hello and welcome to our podcast. Today we are diving into the topic of atmospheric water harvesting or AWH again, a promising technology in the field of water sustainability. Today we have a very special guest who is becoming more famous than many celebrities. Guess. Yes, it is ChatGPT. Hi, ChatGPT. Thank you for joining us today. We are excited to have you here to share your insight on AWH.
Hi, thank you so much for having me on your podcast. I'm thrilled to be here and talk about atmospheric water harvesting, a truly exciting and vital technology for our planet's future. Let's dive in. What's your first question?
As a first question, could you explain what atmospheric water harvesting is and why it is so important?
Of course, atmospheric water harvesting, or AWH, is the process of extracting water directly from the air. Even in dry climates, the air contains water vapor, and AWH systems capture this moisture using various methods, like cooling air to condense water or using special materials that absorb and release water. This technology is important because fresh water is becoming increasingly scarce due to climate change, population growth, and pollution. AWH offers a sustainable alternative, providing clean water in regions where traditional sources, like rivers or groundwater, are limited or unreliable. It has the potential to improve water access, reduce stress on natural resources, and support communities worldwide.
Amazing. Interesting. Let's talk about advancements. What are the most recent advancements in atmospheric water harvesting technology?
Thank you. Recent advancements in atmospheric water harvesting have been very exciting. Here are a few highlights. 1. Advanced materials. Researchers have developed materials like metal organic frameworks, MOFs, and hygroscopic polymers that can capture water even in low humidity environments. These materials are highly efficient and can significantly boost water collection rates. 2. Solar-powered systems. Combining AWH with solar technology has been a major step forward. Solar panels not only provide energy for the system, but also help regenerate materials that absorb water, making the process more sustainable and cost-effective. 3. Passive systems. Innovations in passive AWH systems use natural cooling or temperature differences to condense water without requiring external energy. These are especially useful in remote or off-grid areas. 4. Biomimicry. Scientists are drawing inspiration from nature, like desert beetles and plants, to design surfaces that can efficiently capture and channel water droplets. These advancements are making AWH systems more efficient, scalable, and environmentally friendly, bringing us closer to addressing global water challenges.
Can you describe one or two innovations that you find particularly promising?
Absolutely. One of the most promising innovations is the development of metal organic frameworks, MOFs. These advanced materials can capture water vapor from the air, even in humidity levels as low as 20%. MOFs act like sponges for water, absorbing it from the air and then releasing it when gently heated. Their efficiency and adaptability make them a game changer, especially for arid regions. Another exciting innovation is solar-powered hydro panels, like those developed by Source Global. These panels use sunlight to power the entire water harvesting process, from collecting moisture to purifying the water. They are highly efficient and operate completely off-grid, making them ideal for remote communities, disaster relief efforts, and even homes in water-stressed areas. Both innovations represent the potential to provide sustainable, clean water solutions while minimizing environmental impact.
Wonderful, wonderful, very amazing, wonderful, interesting. What challenges do researchers and engineers face when trying to scale AWH technologies?
That's a great question. Scaling atmospheric water harvesting AWH technology comes with several challenges. 1. Energy demand. Many AWH systems, especially those based on cooling or condensation, require significant energy input. Making these systems energy efficient, particularly in off-grid settings, is a key challenge. 2. Material costs. Advanced materials like metal organic frameworks, MOFs, or specialized coatings are often expensive to produce. Finding ways to reduce these costs without compromising performance is crucial for large-scale adoption. 3. Climate variability. AWH systems rely on humidity and temperature, so their performance can vary widely across different regions. Designing systems that are effective even in low humidity areas is an ongoing challenge. 4. Water quality assurance. Harvested water needs to be filtered and treated to ensure it is safe for drinking, which can add complexity and cost to the systems. 5. Infrastructure integration. Scaling AWH often requires integrating it with existing water supply systems, which can be logistically and financially demanding, especially in urban areas. 6. Public awareness and acceptance. Educating communities and stakeholders about AWH's potential and benefits is essential for widespread implementation. People need to trust and adopt the technology for it to succeed. Overcoming these challenges requires innovation, investment, and collaboration among researchers, engineers, policymakers, and industries.
Please let me have one simple follow-up question. How can we overcome these challenges to make AWH more accessible and efficient?
That's a great follow-up question, and it's not simple. It's actually at the heart of advancing AWH technology. Here are some strategies to overcome these challenges. 1. Lowering material costs. Investing in research to create cheaper, scalable materials like improved MOFs, zeolites, or bio-inspired materials can make AWH systems more affordable. Mass production can also reduce costs significantly. 2. Energy efficiency. Pairing AWH systems with renewable energy sources like solar or wind can make them more energy efficient and sustainable. Passive systems that require little to no energy, using natural temperature cycles, are another promising direction. 3. Climate adaptation. Developing technologies that work effectively in a wider range of humidity and temperature conditions is essential. For example, materials that absorb water even in low humidity can make AWH viable in arid regions. 4. Simplified maintenance. Designing systems with self-cleaning materials or minimal moving parts can lower maintenance needs, making them more user-friendly and reliable. And 5. Local customization. Tailoring AWH systems to specific regional needs, such as community size, local climate, and water quality requirements, can enhance their effectiveness and acceptance. 6. Policy and incentives. Governments and organizations can provide subsidies, grants, or tax breaks to support AWH adoption, especially in underserved areas. Including AWH in water resource management policies can also accelerate implementation. 7. Public awareness. Educating communities about AWH's benefits and reliability can build trust and encourage adoption. Demonstration projects in schools or public spaces can also inspire confidence. By focusing on innovation, collaboration, and public engagement, we can address these challenges and make AWH a widely accessible and impactful solution for water sustainability.
Many thanks. Perfect, interesting. Let's talk about real-world application. Can you give examples of where AWH technology is currently being implemented successfully, and what impact have these projects had on their communities or industries?
Absolutely. Let's start with your first question. Examples of successful AWH implementations. Source global hydro panels. These solar-powered panels are being used in remote villages in India, Africa, and the Middle East. They provide clean drinking water by extracting moisture from the air and using solar energy to power the process. Wineries in California. Some wineries use AWH systems to generate water for irrigation, helping them maintain sustainable practices during drought conditions. Middle Eastern agriculture projects, advanced AWH technologies, are being deployed in desert regions to support farming by providing water for irrigation, enabling food production in otherwise uninhabitable areas. Disaster relief efforts. Portable AWH systems are being used in disaster-stricken regions to provide emergency drinking water where traditional water supplies are disrupted. Now for the second question, impacts of these projects. Improved access to clean water. In remote and arid areas, AWH systems provide a reliable source of potable water, improving health and reducing time spent fetching water. Increased agricultural productivity. By providing water in desert areas, AWH supports farming and food security, boosting local economies. Environmental benefits. AWH reduces reliance on groundwater, preventing overextraction, and cuts down on the use of bottled water, reducing plastic waste. Enhanced resilience. Communities and industries become more resilient to climate change and water shortages, ensuring stability even in extreme conditions. These examples show how AWH is already transforming lives and industries, providing a glimpse of its immense potential.
Perfect. Very interesting. Now I would like to talk about future. What do you see the future of atmospheric water harvesting technology in the next 10 years? And what are the key areas where you believe AWH needs innovations or research focus?
Great questions to wrap up with. Let's look ahead. Where do I see the future of AWH technology in the next 10 years? In the next decade, I believe WH will become a mainstream water source in various sectors. Urban integration, AWH systems could be integrated into buildings, turning rooftops and walls into water-generating surfaces. Smart cities will likely adopt this technology as part of their sustainability efforts. Agriculture. AWH will play a bigger role in irrigation, especially in arid and semi-arid regions. With improved efficiency, it could support food security on a larger scale. Emergency response. Portable and lightweight AWH units will become a standard tool for disaster relief, providing immediate water solutions in emergencies. Global adoption. As costs decrease, AWH systems will become accessible to low-income communities, helping address water scarcity globally. Climate change resilience. AWH will be an essential tool for adapting to changing water availability, offering a decentralized and reliable water source. Key areas for innovation or research focus. 1. Advanced materials. Developing cheaper, more efficient materials like MOFs, zeolites, or bio-inspired designs to capture water even in low humidity environments. 2. Energy efficiency. Creating low energy or passive systems that can operate without electricity or integrate with renewable energy sources like solar and wind. 3. Scalability. Designing modular systems that can scale up or down, making them adaptable for households, farms, and industrial applications. 4. Water quality. Innovating filtration and sterilization methods to ensure harvested water meets or exceeds drinking water standards without adding significant cost. 5. Cost reduction. Reducing manufacturing and maintenance costs to make AWH affordable for developing countries and off-grid communities. 6. Policy and awareness. Encouraging government policies, subsidies, and education programs to drive adoption and public trust in AWH technology. 7. Climate-specific solutions, customizing AWH systems for different climates, such as extremely arid deserts or cold regions with low humidity. With these advancements, AWH has the potential to become a transformative solution for water sustainability, addressing challenges from urbanization to climate change.
Wonderful answer. That brings us to the end of our discussion. Thank you, ChatGPT, for joining us and sharing such valuable insights about atmospheric water harvesting.
Thank you so much for having me. It was a pleasure sharing insights on atmospheric water harvesting and discussing its potential to transform the way we think about water sustainability. And to all the listeners, thank you for tuning in. Stay curious and keep exploring solutions for a better future. I'm looking forward to joining you again for more exciting discussions. Until next time, take care.
And a big thank you to all our listeners for tuning in. If you have any questions or want to learn more, please reach out through our social media channels. And don't forget to tune in next time for another episode. And take care. Thank you.